Hello, are you listening me please? Hello, are you listening? Good morning. Dear students, are you listening me? Hello, Raita, are you listening me? Dear students, welcome to my second biology class. Hopefully you are well. I am also fine. In my last class, we discussed about heredity materials, chromosome, DNA, RNA. We have already discussed the structure of DNA, structure of RNA, also comparison between DNA and RNA. Today, we will discuss about genes, mechanism of gene action, Mendel's law, and DNA replication. So, our today's topic is divided into 4 parts. First of all, gene. Gene is the unit of controlling characteristics. Gene is the unit of controlling characteristics. Before discovering gene, scientists thought that gene is the factor of controlling characteristics. So, you can say gene is the unit of controlling characteristics. Unit of controlling characteristics. Now, the genes, in other words, you can say a specific sequence of nucleotide in a DNA or RNA that encodes for protein synthesis is called gene. Or simply you can say unit of controlling characteristics. Or you can say a specific unit, specific segment or specific part of nucleotide in DNA or RNA that controls a specific characteristics is called gene. Now, one gene may control one character. You will remember this, usually a pair of genes, one gene control one character, a specific gene control a specific character, but sometimes one gene may control more than one character. Sometimes more than one gene collectively may control a specific character. But how the gene actions, how gene acts, how gene functions. We know DNA is formed from old DNA. This method is called replication. From DNA, RNA is formed. This is known as transcription. Okay, new DNA is formed from old DNA by the process of replication, and RNA is formed from DNA by the process of transcription, and by using the codes in RNA, protein synthesis occurs. This process is known as translation. Protein by the process of translation. The protein that is synthesized from the code according to the codes of RNA. At first, this is synthesized. Protein is synthesized in ribosome, and then this protein is stored in endoplasmic reticulum, Golgi body, and from Golgi body through the endoplasmic reticulum, this protein is translocated to a definite place of cell, staying where the gene is active. So, in brief, we can show the mechanism of gene action like this: DNA, RNA, that means RNA is produced from DNA, and according to the codes of RNA, protein synthesis occurs, and protein controls the characteristics. Okay, now we will discuss Mendel's law of heredity. You know who is the father of heredity or father of genetics? Mendel. Mendel is considered as the father of genetics because Mendel invented two important laws of heredity. First law is known as the law of monohybrid cross. Mendel's first law. Or law of monohybrid cross. Monohybrid cross means cross between two organisms having one pair of contrasting characters. Cross between two organisms having one pair of opposite or contrasting characters. Monohybrid cross. Cross between two organisms having one pair of contrasting characters. Okay, before going to explain Mendel's first law or law of monohybrid cross, you should know some terminology. These terminologies are, first of all, allele. Allele means a pair of each of the pair of gene that controls the characteristics is called the allele of other. Each of the pair of gene that controls a character, controls a specific character, is called the allele of R. Say there are two genes here. One of the gene is denoted by capital T, another is denoted by small t. So T is the allele, capital T is the allele of small t, and small t is the allele of. That means this gene is allele of this one, and this one is the allele of. Now, homozygous gene or heredity means a pair of identical genes. A pair of identical genes. Identical genes. Say, example, these are same type of gene, both are dominant gene. Dominant gene are expressed by capital letters or small t small t. These are recessive gene, both are recessive gene. So these are homozygous. And heterozygous, a pair of non-identical gene. A pair of non-identical gene. That means if one of them is dominant gene, other will be recessive gene. This is non-identical, not same. One is dominant, another is recessive. Okay, thank you. Now come to the explanation of Mendel's law. Now I will explain Mendel's law. That is very important for you. In higher classes, intermediate classes, you will learn many things about Mendel's law, exception of Mendel's law, use of application of Mendel's law, etc. But this year, you will learn only the explanation of the first law of Mendel's first law, monoid law of monoid. According to this law, if a cross is made between two organisms having one pair of contrasting character or opposite character, then only the dominant characters is found in first generation or F1 generation, but in the second generation, F2 generation, both dominant and recessive characters are found in the ratio of 3:1. Okay, that means if you make a cross between two organisms that have one pair of opposite character, contrasting character, then in the first generation you will find only the dominant character. No recessive character is seen in the first generation, and in the second generation you will find both dominant and recessive character in the ratio of 3:1. You can use this as the statement of the law. Now, how to explain this? Now I will explain this law. You see, Mendel carried out his experiment with the help of pea plants. For explaining his first law, he took two pea plants. One of them is tall, another is short or dwarf pea plants. Let the gene responsible for tall character or tallness be capital P. You know, one pair of gene controls a character, so the genotype of tall character, therefore the genotype of tall pea plant is capital P. As one pair of gene controls a specific character, so genotype of genotype of tall P plant will be capital P, capital P. Again, the gene responsible for dwarfness, say small p. Therefore, the genotype of dwarf or short p plant will be small p small. Okay. Now we will carry out cross between these two organisms, because this organism has tall character and this has short character or dwarfness. So if we now we can carry out the cross between these two organisms. We consider the tall, that means capital P, we consider these as male, this is the male side, and we consider the dwarf plant as female, this female side. Now you know, before going to sexual reproduction, they will produce gamete by the process of meiosis, subdivision, gamete is produced. There are two gametes, capital P will be produced. There are two gametes, small p, small p. Now cross between them. Okay, capital P small. Because this will get capital P small. If you cross capital P small, again capital P small p. So here this is the first generation. Okay, these are the parent one, that is first parent. These are the gametes, and this is first generation. Then we find by crossing among the gametes, we find the first generation. Here you see, Mendel found that all the P plants are tall, but these are homozygous or heterozygous? Heterozygous. These are heterozygous. All are heterozygous tall. That means in first generation, no dwarf pea plant, no short pea plant was found. All the pea plants are tall and all are heterozygous. Now, taking two plants from F1 generation, we will cross in the second generation. Now, you say parent 2, that means I will take two plants from here. Say the main plant is small p and another is small p. I have taken two plants from the first generation. Now I will do the cross. Again, in the same way, they will produce the gametes by the process of meiosis. Here meiosis will occur and gametes will be produced. Particular gamete, capital P small p. Here will also be gamete, capital P small p. Now you can cross this. The result of this cross, you can represent the result of this cross. You can represent in checkerboard also as like as before, like this. If you cross between these, then capital P, capital P. If you cross this one, capital P, small p. If you cross between these, capital P, small p. If you cross this one, then small p, small p. Here you see, this is tall. No doubt this is tall and this is homozygous tall. This is short, heterozygous tall, heterozygous tall. This is also tall, heterozygous tall. But this is short because there is no dominant. That means here we can express this with the help of checkerboard. You can show these in the checkerboard also, or like this, no problem. With the help of checkerboard, this. So these are male gametes, these are female gametes, and the male gametes, Now cross between this capital T, cross this capital T small t, cross this capital T small t, cross this small t small t. So what it is? This is tall, and homozygous tall. This is also tall, but heterozygous tall. This is also tall, but heterozygous tall. This is dwarf, and homozygous tall. Therefore, in the second generation, what we find in the second generation is the result of second generation. Result of second generation. In the second generation, what we find? Therefore, the phenotypic ratio, that means phenotype is the external expression of gene, and genotype is the genetic constitution of gene of type. The phenotypic ratio in F2 define tall is to dwarf. How many tall are here? 1, 2, 3. And how many dwarfs are here? Only 1. This is the phenotypic ratio. Mendel said the same things. That means in the first generation, no dominant character will be seen, but in the second, sorry for the interruption. And in the first generation, no dominant character will be found, but in the second generation, you see both the dominant and distinct characters are found in the ratio 3:1. This is the phenotypic ratio. Now you see the genotypic ratio. Genotypic ratio. What are the genotypes found here? What are the genotypes? One type of genotype is capital T. Then another type of generation is capital T small t, and another 3 types of genotype is found small t small t. What is the ratio? What is the ratio of this? How many capital T is found? 1. How many small t? 1, 2, and 1. This is the genotypic ratio. Okay. Thus, this way we can explain the Mendel's first law. And frequently it comes in your exam. Mendel's to explain the Mendel's first law. While explaining this, you will remember that first you will state the law. Then you will explain Mendel's law with the help of the symbols, taking genes like this that I have already explained you. Then DNA replication. Now I will discuss about DNA replication. DNA replication. Replication means the process of making copy. That means the process by which a new DNA is formed from an old DNA. The process through which a new DNA molecule is formed or synthesized from an old DNA is called DNA replication. But how this replication works? How the new DNA strand is formed? Say this is a DNA. Okay, say this is the DNA molecules. You know there are 2 strands in DNA molecules. If there is adenine, there is nitrogen bases. These are the nitrogen bases. Okay. In the beginning of DNA replication, the two strands will be separated from each other by breaking the hydrogen bond between them. How the strands will be separated? Say these 2 strands are separated. These 2 strands are separated by breaking the hydrogen bond between them. This bond is broken and 2 strands are separated. Like this. Okay. Now, these 2 separated strands will use their template strand. That means these will act as template. This will act as template strand. Old strand or template strand. By using the old strand as template strand, new strand will be synthesized with the help of new nucleotides, and this process is done by DNA polymerase enzyme. With the help of DNA polymerase enzyme, here is a new strand will be produced. As here is adenine, so here will be thymine, and it is guanine, so it is cytosine, and it is cytosine, so it will be guanine, and it is cytosine here, so it will be guanine. And then the bond will be formed. Here will be double bond, triple bond, triple bond. The same as by using this old strand, a steplet strand, another new strand will be formed here. Cytosine, guanine, guanine, cytosine, adenine, thymine. Now the bond. Okay, so here you see the new two strands are formed. These two strands will be again rewinded. Again required a rewinded like this. This will be rewinded like this. So this is a new DNA molecule. This is another new DNA molecule. Here you see, in both the new DNA molecules, one is old strand. This is old strand. This is also old strand. But this is new strand. These are new strand. So you see here, in both the newly formed DNA molecule, always one old strand is conserved. Okay. Now you see between these two strands, this one is old strand. Between these two strands of the DNA molecule, this strand is old strand, this one is new strand. So, in a newly formed DNA molecule, always one old strand is preserved or conserved. That is why this type of DNA replication is called semi-conservative method of replication. Semi-conservative, why semi-conservative? Because half portion, that means one strand of the DNA is always conserved or preserved. For this reason, this type of DNA replication is called semi-conservative method of replication. Okay, again for your understanding, I am again explaining this. At first, the DNA strands, these two strands will be separated by breaking the hydrogen bond with the help of helicase enzyme. Helicase enzyme helps to break the hydrogen bond. These bonds are broken by helicase enzyme, and the two strands will be separated. These two separate strands will act as template, and based on this template, with the help of DNA polymerase enzyme, with the help of DNA polymerase enzyme, new strand will be formed based on the template strand. According to the template strand, new nucleotide will be added by DNA polymerase one after another, and new strand will be formed. Thus, when the new strand will be formed, then the old strand and new strand will be rewinded again. Again, they will be rewinded. Thus, in a newly formed DNA molecule, always one old strand is always preserved or conserved. As one old strand is always conserved or preserved in a newly formed DNA molecule. That is why this type of replication is called semi-conservative method of replication. Okay, dear pupil, we are almost at the end of the class. If you have any query, any question, you can make your question in your respective groups. I'll try to give you the answer. And another thing I want to make you remember that the whole country is in epidemic state of coronavirus. We all should be very careful of this. We will maintain cleanliness. We must rub our hands with hand sanitizer, or we will wash our hands with soap. We will wash our hands with soap and other things before touching our nose and mouth. Especially while you will touch your nose and mouth, you will rub your hands and fingers with sanitizer or with soap water. Then you can touch your mouth. Otherwise, you should not touch your nose and mouth, because these are the entrance of COVID virus or especially news and these data centers into our body. So we will be very careful. We will keep ourselves healthy. We will stay home and we will stay blessed. Thank you all.